Hi, everyone. Thank you for joining us for this webinar, Driving Higher Farm Margins with Precision Agronomy, presented by FarmQA and Planet. We're at time now, so I'm going to go ahead and get started with a few housekeeping items just while everyone gets settled. And first off, hi, I'm Mariah Hauk. I'm the Marketing Campaign Manager here at Planet, but today I'll just be on the back end helping out.
Hello, my name is Ariel Zajdband. I'm a lead product manager here at Planet. I'm joining from our San Francisco office, and today we'll be presented with Ben from FarmQA. Ben, are you here?
I am. Hello. Thanks for having me.
Thank you so much. So I'll start presenting some general slides, and then I'll pass it to Ben. Okay. So to start, we are going to start with some hard numbers. If you can see this graph, like the blue line is basically what it costs to run a farm, like seeds, fertilizer, equipment. And the red line is actually showing what the farmer gets paid for their crop. So what you can see is that that gap is hitting a 10 years high. That means that the margin of error is disappearing from farming, right? We are no longer in an era where good enough management is good enough. We need to actually optimize our management to keep the farm profitable. This is a t-shirt. I didn't buy the t-shirt, but I got a picture from this t-shirt I got in Michigan State actually a few years ago. And I think that this quote is actually a famous quote, sums up why farming is such a difficult business. We know that farmers are price takers on both ends. Farmers cannot control the price of diesel, the price of the equipment, but also cannot control the price of corn, right? So the challenge is to use efficiently each input that we have. This picture I took in the field also a few years ago. It's an extreme case. I invite you to try to guess in the chat what actually happened in this field. But what I'm trying to say here is that we cannot keep treating the one field the same way. Things like this happen, and again, I invite you to guess what's happening throughout this kind of. You can argue that it's a field trial, but it's not. It's actually a mistake. But in this world of tight margins, we can no longer manage a field for the average. That's not a way of being efficient. And that's why we believe that our satellite data is so relevant to understand and manage that field variability. Our friends from FarmQA will explain how their tool and their solution can be used to manage and monitor fields. But in our case, from the Planet side, we have our super DAB fleet, which is composed by hundreds of satellites that are collecting data on a near real time and near daily at a resolution of 3 to 5 meters with 8 multispectral bands that can be used for calculating different vegetation indices and then understanding field variability. So I'll let Ben present. So I'll pass it to Ben here. So you can share the screen and take it from here.
Perfect. I've got it. I appreciate it. Thanks for the intro. Just a bit more about me and who we are. So my name is Ben Munson. As Ariel mentioned, with FarmQA, we are a partner of Planet. And with that, have been for several years now. And I've got some use cases that I'll be walking through around how we can utilize Planet's data to make more informed decisions and as alluded to, sub-field level management decisions. But first, a little bit more about who we are at FarmQA. Me personally, I've been with FarmQA here for 10 years. And with that, we've been actually, I was employee number 1. So we've been around for 10 years, and with that, have set out to build an agronomic data tool set. And so with that, it's a software platform for anybody who's doing agronomy work, whether that is a true maybe agronomist at a retail co-op or a grower or on the seed research side. So really, with that, the tool set covers a lot of functionality. And today we're going to focus specifically on the spatial data component as per the topic, but just at a high level referencing, we round out the product with scouting, advice, prescription writing, field journals or application records over time, soil sampling, data analytics, crop planning, chemical planning, fertilizer planning, and then on the top left here, we see imagery and spatial data layers. And so with that, just as I demonstrate the product, you'll see different tabs, but it's to cover any sort of need that you may have throughout the course of a year or a growing season that you need to be focused on data collection or reporting. So with that, I am going to focus mostly on a live demo. I feel that demonstrates our functionality quite well, and we can talk through some use cases. But specifically, those use cases here are going to be around how we handle planet data. So Ariel mentioned hundreds of satellites in orbit. That's been the case for many years, and so we can actually backfill 5 years of planet data within our platform. And us being a partner, one of our main benefits is simply the handling of that large data set. And so as you can imagine, images near daily for 5 years at 3 to 5 meter resolution, that's a lot of data. And so we not only store that, handle it, but we will pull that automatically and backfill at 5 years. And we will process it for different indexes. Most commonly in the ag industry, people talk about NDVI, but I'll talk through other options around M-Savvy, GNDVI, things to that extent. But then in addition, clipping it to your fields. And so with that, those additional processes make that more usable to you as a user, simply from a data handling perspective. So we'll speak to that. Once it's been cleaned and processed by us, you then have the ability to view that within a web or mobile application, which I'll walk through to make it actionable. And some of the things that we'll talk through as far as a scenario here is directed scouting. So we mentioned managing fields for the average versus let's direct your efforts in that field of saying large field, 6-foot corn. How do I go to the best and worst spots to identify particular issues and problems? So that's one use case I'll be going through. As a result of that, let's then treat the field at a subfield level or a zone level. And I'll cover scenarios from a directed scouting concept. We'll kind of flow into a variable rate, maybe herbicide, spot spraying scenario, but touch on fertilizers if on that side too, to manage it for different products and use cases. And then we also do some unique things around handling the raw data. So with that, you can see like some trend lines and looking at a lot of fields at once. So this harvest progress tracker is designed for looking at large regions. Say that could be at a county level, state level, and tracking harvest progress, and specifically how many acres have been harvested for every day that we get a planet image, and then displaying that through a dashboard to make meaningful, high-level decisions. So those are just a handful of use cases. There's a lot more we can do with the data, but for the time given today, we are going to focus in on that. So with that being said, I am going to transition into a live demonstration of the functionality I just referenced. And so with that, what you'll see here is this is our web platform. We are cloud-based. You access this through a website. We talked about different functionality here that you're going to see on the left, but specific to this conversation, we'll talk through, first of all, fields get mapped. You can draw them, you can upload them. We have integrations to seamlessly pull that in. Regardless, you end up with a set of fields tied to crop assignments, tied to growing seasons. That is what we're going to utilize to clip and process the planet data. And so talking through that, this is something we handle really well. It's not overly flashy, but just to kind of set the stage of you can be in the driver's seat for configuring how you want your planet data processed and displayed within our platform. And so in this, you can see the ability to choose different indexes. And when I say indexes, the planet data is 8-band data. So you can combine those bands to come up with different indexes such as NDVI, normalized difference vegetative index, which can then be utilized to look or make decisions around, let's say, crop health, maturity, things to that extent. We have other indexes which you can have processed. And so with this, you can look at NDRE, MSavvy, Redband, GNDVI. And with that, you're configuring your count of what you care to look at or have processed. Secondarily, you can choose the months you care to have processed. And with that, let's say you're in the Midwest, you may only care about April through October. And so that's what you can configure. Cloud cover threshold, let's say, so with 10% cloud cover, let's say you have a field, you get an image. With that, there's 15% cloud cover over that field when that image was captured. This 10% cloud cover would toss out that image, and you'd only get the really high quality images. Or you could adjust that to be whatever you wanted if you wanted to get more images and we're accepting of a higher cloud cover percentage. So again, you in the driver's seat there for choosing what you want to have delivered. Backfill, 5 years, we talked about that, but you can set that up to say, I want the full catalog on a field level of all 5 years. And then again, we'll give you every image that fits that cloud cover threshold, going back to that date process for any index that you have selected. So pretty powerful tool there and efficient. And then finally, with this, you could purchase a block or a chunk of acres that you want imagery on. And again, you are self-sufficient here to select fields. And then as you do that, that consumes your acreage from your quota. And the second I hit update, that data starts to flow into the fields, processed, available on the web and mobile. Again, so I'll move on from this. I know this is just kind of back-end settings, but again, I do think it shows the power of just handling the planet data and making it customized to what your use cases may be. All right, on to more of the interesting data. How do you view that? How do you use it? So first of all, clicking on a field, I alluded to earlier as far as our function set, the spatial data or the layers is where all this functionality lives. So in my scenario, I've clicked on a field, I have layers. I have a couple things to call out here. If I turn on my imagery, that's where this planet data exists alongside any sort of machine data, say zone maps, sampling points, etc. The different indexes, you can select between them. So in this case, NDVI. So within here, I have images pulled up. We have a date picker. Because we're an agriculture-based platform, you have a quick filter by season. So if you want to compare year over year or look over time, you can do that. Or just to prove the case around the backfill, you can see at the bottom here as I slide across this slider, every one of these lines is an image. And so you can quickly snap back into, say, 2022 and look at crop progress for that season in a particular period of time. And so with that, that is just some basic getting oriented type tools. But to speak to this here, we'll kind of slide into the middle of the season. So in this field, we'll look at the middle of July. So in my case, we'll look at maybe July 14th. So our tooling, we've processed it, but the value begins in simply being able to visualize that quickly and efficiently. So in this case, I've pulled up an NDVI image, and I could slide across the different days that we have images from Planet, and you can start to look at crop progression. So with that, if you look at that red dot in the top right, you can see how that's shrinking over time. And so it's trends like that visually that you can pick up on through just kind of the quick processing of the imagery and displaying of those scenarios. But in addition, we have the different indexes. So we allow you to toggle between those, and we'll hold that date fixed. And so you can compare your visual bare ground or bare image to the NDVI, to say the NDRE, to the MSavvy. And with that, those are using different bands to try to extract different maybe issues depending on the timing of the year. If there's more maybe bare soil exposed versus full canopy, you'd want to use different indexes throughout the year for that. So with that, setting the stage, viewing the imagery, being able to interact with that over time. What we can do here as well is we can specifically look at a particular period of time. So I'm going to look at, in my case, just the month of June. And with that, if I want to look at a field level, that's what we just covered. You can always take a step back in our platform and say, I want to see what's going on across all my fields, across an entire maybe client or grower. And so I wanted to show this ability to take a step back and look at maybe trends at a water level. And you could zoom this out to state level, to whatever you need it to be. In my case, let's just talk through a scenario where a hail event moved through an area. You have the ability to see that visually where you have damaged fields versus not. And you can see the processing here of, as I slide through, a very efficient processing speed to be visualizing that at a farm level or a region level. From here, we'll talk through our first use case. So we've processed the data, we've visualized it, moving into a practical in-field use case. With this, I'm going to pull up our mobile application. And so with this, I have a very similar view as we try to keep this. So I'm trying to zoom in a little bit. We keep this efficient as far as having the map view be your basic visualization here. So it's a similar look and feel to the web. As I click into that same example I had before, it pulls up that particular field. I have the ability now to see the field, see my location, and the scenario we're going to talk through now is directed scouting. So as a scout, I can get turn-by-turn directions through this little arrow icon. When I get to the field, and let's say I pull up to this southeast corner, this is a 130-acre cornfield, and let's just say it's 6 feet tall, and I want to be efficient with my time. I can't logically cover this whole field in a scouting visit, so I'm going to turn on my imagery layers. So similar to the web, I can toggle on the imagery, and I can toggle between my different layers. So I've got the visual along with the dynamic NDVI. And in this view, just like the web, I can slide through and see the crop progression and the images processed and viewed on the mobile app. And so with that, I talked about our GPS. And with that, let's say my mouse is your GPS location. I visually see up here, I want to know what's going on with that patch, that lower NDVI values. What that NDVI is good at is finding the variability and showing you how that field is varied, but it can't tell you specifically that this red area is because of drowned out or aphid damage or it's weed pressure. And so in that, that's where you can use your GPS and you could walk to that area. And you could then use our functionality around tracking a scouting observation, taking some images. So we'll say weed pressure here. Otherwise, the field looks good. Within here, we have the ability to then define. So with that, let's say we're specifying, in this case, that the weeds, it's leafy spurge that I found, a patch of that. So I select the weed, maybe I designate the pressure, weed height, and then I had the ability here to take an image in the field. So with that, all that is going towards, we helped you navigate in the field, you got to the spot, you documented what's going on. Now you're going to report this back. Scenario may be you're a junior scout reporting to a head agronomist. Maybe you're a grower just looking to use that information and spray, or an agronomist reporting back to a grower what you saw. So in that, your efforts are directed, you get to that area, and then you quantify what is causing that drop in NDVI, what's going on there. And then that can be produced or used to produce a report. So on the other end, you have a report, professional looking report with your logo on it, the client, where you were in the field when you checked it, along with the ability to include that planet image on the report itself. And so this is valuable if it's going external to a user to encapsulate the actions you're going to take, what you saw. So there's a picture of the leafy spurge, documentation around the pressure, etc. So with that is kind of the directed scouting. But then the follow-up to that is, actually, I'll pause it. So on the mobile side too, one last thing I want to call out, we sync down the satellite imagery. So if you lose connectivity, so you might be saying, I saw something that's from Great Sky, Montana. You're scouting, you lose connectivity in Montana, we still have this imagery to display. So everything I'm showing you here, you can still do with slide those images because we've synced them down to your device. And in addition, your GPS is still displayed as well, so you can navigate throughout the field just the same. So with that, we'll transition and say you've done the work in the field, you've identified the issues, and you've been efficient around targeting the best and worst spots. Now let's use that planet imagery and further treat the field independent with just those leafy submerged spots that you want to spray just at a spot spray level instead of treating the entire field. So to do that, I'm going to come back to our web platform. So logically, you've gone to the field, you've done the check, and now it's time to come back and let's take the action. Let's write a prescription or a recommendation for that client. So to do that, I'm going to pull up that same image here from the web. So I've got, in my case, I was using the, I gotta adjust my time filter here. I was using the July image that I felt like represented the most variability in the field. So this was when I checked the field. Let's say I know there's additional images, but let's just say it's July 12th. I need to write this prescription, and we're going to just treat those red areas with a herbicide application. So in that, our tooling allows you to take this image, and we'll call this the Planet webinar. I can choose, do I want to break this into 5 different rates, 3 different rates, 2 different rates? And that's essentially this is the zone tool of saying 2 different application zones, and I don't want any zone less than an acre. So as I do this, you'll see these red areas get extracted into these different management areas. And so what's happening here is we're using that Planet high resolution image, and that fidelity on the image reflects into the detail, the quality of those different areas. And more specifically, what's happening here, so I'll create that again, but we'll do 3 zones this time. So what's happening is that NDVI data, with that, the 3-meter data, we have a pixel every 3 to 5 meters. And that pixel has a value which represents essentially, how green that value is. And so with that, you can see how many values fell within different ranges here. But what we're allowing you to do here is we're creating these different breakpoints or groupings of that NDVI imagery. And so in this, you can see, we programmatically sliced it out and broke it into groupings. But you could say that red area, after I was out there, I want to shrink that down. And likewise, that yellow area, I want to further reduce the size of that. And so in my scenario here, I'm going to talk through, we want to do 3 rates. I want to do on that red area, that's where we have the biggest weeds. I'm gonna apply the highest rate there. The yellow areas, I'm gonna put an in-between rate. It's kind of the fringe areas where that might spread to. Let's kill the seed base. Green, we're not seeing anything there. We're not gonna apply any herbicide. So in that, you can see as far as acres go, we really only need to apply this across 26 acres instead of traditionally this being across 130 acres. Saving on chemical, sustainability wise, you're only treating the areas that need it and you're being efficient. With this, agronomically, you might know some value add from your side. You can look at this and say, well, the southeast corner, I know that's actually a salt issue. It's not related to weeds or it's a drowned out. You can agronomically, I call this your agronomic paintbrush. You can dissolve that zone out and say, we're not going to treat that area, and I'm just going to kind of override the data set, knowing that that's a separate issue that caused that. So from here, now what we can do is we've created those break areas, you've customized them. Now we're going to come through and say we're going to apply 2,4-D is how we're going to control that leafy spurge. So we put in our product, and with that, we now have the ability to say with those different areas, I'm going to treat that high area with a 2 quart per acre rate. So again, really need to treat those big weeds. That kind of transitionary zone, we're going down to 1 quart per acre. Green zone, we don't need anything. And so in that, you're seeing you've got an average rate if you need to report out like an application record. You've got this total quarts needed across that, and that factors in the area needed and the rate. And we'll say that this is spot spray for leafy spurge, June 25. So in that, you can then export this. So you get a shapefile at the other end. And so a shapefile is machine readable. As the applicator goes out there, they plug that file into the monitor. It enacts that application, meaning that as it moves east to west, it will automatically kick in that 1 quart rate, 2 quart rate, and the applicator just moves to the field and does that. And so our system will kick out that file that dictates those rates and changes the rates at the machine level. Additionally, you can get, similar to the scouting report, you can report this back to any user that needs to see a report of what's going to happen, my 2,4-D treatment. You can show this as a record or get an order done for it, but you can see total acres in the field versus what actually got covered was only 15. This is a slightly different scenario I did here, but the average rates and the total product included. So in that, it's the concept of, again, directed scouting. Well, first of all, the planet imagery processed. When you got to the field, we saw the variability. The person boots in the ground quantified what drove the difference in those areas in the field. And then you took action, which was a variable rate application around treating those areas. Finally, I want to kind of round things out here. We're talking a lot about at a field level. We have some tooling in here that allows you to make decisions that are maybe less visual and more analytical. And so what I'm going to show here is if I pull up an image, and we'll show this kind of in-season image here again. But with that, you can visually see where there's variability. But with that, you might want to start to look at trends across fields or over time and make these higher level decisions about the field. So how we go about that is you can see in this case, this is an average NDVI value per planet image that we get projected across the season. So speaking practically here, you can see when emergence happened, you start to get more green, if you will, in the field in the early season. You see the crop growth, canopy closure when that's at its peak, desiccation or plants dying off. And so you see that growth pattern. Now we quickly, because we backfill 5 years, you can start to compare that across seasons. So you could say, the last time I grew canola or corn, the same crop, what happened? Well, we can see in 23 that crop was slightly healthier, more green, if you will, and we planted earlier. So it's a shift in saying we are having a later season in 2025. We didn't quite hit that peak that we did last time, and maybe use that to make yield estimations, harvest timing projections. And you also can compare it to the average. So you could say, well, this year is way behind average as far as when we typically plant this field and how that's handled. So at a field level, being able to do some visualizations like that, and then finally taking a step back from there as well, where you're saying, now I've got 30 fields, 40 fields, 50 fields, and I want to triage and see which fields do I need to pay the most attention to, which one should I go scout or treat. And so in this, these are NDVI lines across multiple fields. And I just took a couple just to keep the visualization cleaner. But you can see, actually I'll use these two. You can see these two fields, same crop, black field. You can see how that was progressing throughout the season. You're seeing a lot of growth, fast, healthy field, whereas this one was stunted. And so with that, you say, was there maybe a hail event that knocked that field back? Are we dealing with some disease issues that are just not causing that to be as productive? And so those types of views allow you to look at, again, a lot of fields at once and triage across your operation, which ones you should focus on. And then that can kick off the whole process we talked about field level actions and treatments. And then same concept here, you can look at more of a list view of saying average NDVI values over here, where each row is a field, and you stack rank those at a field average level to look at what are my best, worst fields, kind of at a programmatic approach for that. So with that, I think I am up on time here. So with that, I appreciate those use cases. We're gonna, or you let me walk through those use cases. We're gonna flip back to the slides here, and with that, hopefully there's gonna be some good Q&A based on these scenarios. But with that, we're gonna open it back up for Q&A for either myself or Planet.
Great. Thank you so much for that overview, Ariel, and that really in-depth demo, Ben. I'll give you a second here to take a breath and have a drink. It's really exciting to see the power that is unlocked when we're working together. So like Ben mentioned, we're going to switch over to the Q&A portion. So feel free to drop your questions in the Q&A tab, and we'll get to as many as we can in our remaining time. I think we've got a good chunk left. And we do have both Ariel here and Ben to answer questions. And I think I will just dive in. The first one here is from Anurag, and they want to know what is the resolution for the data I get? I have small plots, for example, Sentinel-2 gives 10 meter.
I can take that one. The planet scope resolution is 3.7 meters per pixel, meaning a 3.7 like each side of the pixel. So yeah, that's a spatial resolution. And we like our data in agriculture is not only the value add is not only in terms of the temporal aspect, the frequency, but also, as you mentioned, for in small plots, having more pixels makes a big difference.
Right, and they had a follow-up question, which also for you, Ariel. Can you just tell us what the frequency of the data collection is one more time?
So it's near real, like it's almost every day. Like so yeah, that increases the likelihood of getting more images, in particular in cloudy areas where the more shots we take, the higher the likelihood of having more cloud-free data.
Right. And then there's a couple related questions on frequency, so I'll just jump to those. Can you tell us what's the advantage of its image frequency? So we just mentioned that it's near daily. So what's the advantage of that over other platforms that don't update near daily?
Like I'll make a comment and then Ben, maybe you have more, but I don't know if you saw the what Ben showed, the graphs, right? The NDVI time series. Each point there is a date. If you have fewer points, that curve that where you're representing the field dynamics will be less populated. So the representation of what actually happened in the field will be not as close as what actually happened because you don't have that many observations. Imagine going to a field once a week, or going to a field every 3 days, or going to a field every 1 month, only one time every month. So that's kind of conceptually the difference. But I don't know, Ben, is there anything else?
Yeah, I mean, I throw a couple of things in there too. Look, we have clients that work in very cloudy regions as well, and so the comment was thrown out there about Sentinel data. So with that, let's say you're near Lake Michigan and Sentinel passes every 7 to 10 days. Well, if there's a cloud in that 7 to 10 days, you got to wait another 7 to 10 days to get another shot. And so that's it as well. You just get more chances, more attempts. So with that, with the near daily, even if there's 1 day out of 10 that's clear, you have a much better shot at getting that with Planet. And the other thing I'd say too is my scenario of the variable applications. What a lot of our clients like to do is look back. I referenced this in the Midwest, at least. This June, July is a good time frame to look for variability. Well, in that, if you don't get a good clear shot in that window for that year, then you're looking back to historic years to find a good variability image. So with this, your catalog is so much bigger, so your options to choose and find the right image that then drives your zones, that drives your actions is so much more expanded.
Great. This next question is from Rob. They're saying, assuming there is cloud-free imagery, is it fair to say you can use the imagery and tools to determine exactly what day a field was seeded or planted?
Like I can maybe take on it, and what we are looking at from satellite is the signal from the crop in general. So what you are determining there is emergence, is not the actual planting date. In remote sensing, sometimes we call it green update because it's the time where we get enough signal from the crop Now, in many cases, what you can do is you can look at growing degree days from emergence and kind of backtrack and say like, okay, I expect this many GDD from planting to emergence and estimate, but that's the in most cases the way of detecting planting date with remote sensing. There are other ways. In particular, there is and I'm not going to go to detail here, but there is some experience in Australia where they were looking, because of planet frequency, and they didn't have any clouds there, at when you go with the planter over a no-till field, sometimes the texture of the field changes, like the texture of the image. So you can detect the planting date by looking at the actual differences in image texture, but you have to be in a no-till field, and you have to have a very good coverage over that area.
Next question is from Neil. They'd like to know about the archive of imagery. So this is for FarmQA. Neil says, I've only been part of FarmQA for 1 year, but can I still get the past 5 years of images?
Yeah, absolutely. So the way it works is day one, when you sign up to receive Planet Imagery, we will start backfilling that 5 years. So the answer is yes, absolutely. And then you also get images from that day for a 12-month period going forward. So essentially, collectively, it's going to be 6 years worth of data, and we'll backfill it immediately when you subscribe that field.
Great. A question from Ruben. Can you download the planet images used for scouting or zoning and keep them for your records and potential analysis later on?
Yeah, I can actually show that one if you have time, but the short answer is yes. So within that view where I was kind of starting the creation of my zones, there's a download button in that, and so it will give you kind of the output of that within that screen, or download of that.
Great. And Madhumita has a couple questions here, so I'll give them one by one so I don't overwhelm you here. Can you tell us, how do you handle detecting multiple crops in a field?
Yeah, so for us, I mean, the answer is we don't necessarily, we're not going to look at a random field and say it's corn versus canola. What we'll do is our customers will define those delineations. And then from there, then you kind of proceed with breaking that into these sub-field actions within our platform. And so with that, our customers will define where the configurations are across crops, varieties, and then they subscribe those chunks to receive imagery, is how that works in our system.
Great. And a related question we got a couple times is which crops are supported in FarmQA?
It's a pretty exhaustive list, and so we support, and actually one of our biggest strengths is customization. And so with that, we support a lot of crops, and it's a list that's maybe 50, 60 long. And the short answer is any crop you grow, we can support, and reach out to me with any particular use cases that you have in mind.
Amazing. I think we can squeeze in a couple more here. This one's also from Madhumita. What indices do you use for harvest progression, or what do you recommend?
Gotcha. So we use kind of a proprietary approach on that. But with that, it's constant to looking at how green it is, and then if there's a change in that value, kind of the derivative of that. And so that's kind of our approach, is looking at from space, you're looking at how green that field is, and then when that changes.
Great. And we're getting a couple questions here from Mark and Bruce and a few others on the cost of FarmQA. So I don't know, Ben, if you want to give a little spiel that might lead into my next slide.
Yeah, sure. Well, so our pricing is very open. It's on our website, and we can link to it. But the short answer is you pay for an account, so $800 if you're just a single user, $800 for the year gets you access to the platform, and then Planet is a per acre fee on top of that. There are add-ons for the kind of variable rate prescription tool. There's add-ons for if you want to have growers accessing the system. And so there's kind of more specifics to it, but the concept is $800 plus your planet fees, and that would be your base package. And we also have some new pricing we're rolling out on the planet side, which I can go to now, which is one of our
Sure.
main kind of call to actions here.
Yeah, thanks. We're running up on time, so I'm closing out the Q&A, and I have just a couple things to share with you before I let you go, this being one of them. So thanks for the setup there, Mark and Bruce and whoever else asked about pricing. So we have a great offer from Planet and FarmQA. So if you're excited about what FarmQA showed and want to take advantage of their capabilities, you can get Planet Imagery at 85 cents per acre per year, plus 160 free acres until October 31st of this year. So on top of what Ben mentioned, you can use this QR code here, or access the link in the resources section to learn more, and that'll take you to the FarmQA site to complete.